This conference will now be recorded.
All right. So my name is Adam, and in this session, we'll try to understand majorly what exactly packaging management is all about. Okay. So in that way, how does Helm help us in Kubernetes to do the packaging management? And we'll also try to go through different components of the Helm and what are the commands that we have in Helm to manage the package within a Kubernetes cluster. Okay, and typically there is another part of Helm where we need to know how do we create a chart or a package by ourselves. But for the current session, I'll be focusing only on the first part, and the chart creation we'll take it up later in some other session. Okay, so with this, let's get started. And before I jump in, let's first understand the basics of what exactly is a packaging management. Now, if you take any Linux machine, if you want to install a software, which is what we call it as a package, right? So what do we do? So ideally, we take help of some packaging manager, which is specific to that operating system that we are working on. Now, for example, let's take Ubuntu. Now, in Ubuntu, if you want to install a software or a package, then you would be using a specific packaging manager like apt, correct? Now, using this, what and all you will be able to do. So if you want to install a package or uninstall a package or upgrade a package, all those things will be done with the help of this packaging manager on the Ubuntu OS, right? So this way, for different operating systems, you will be having different packaging managers, which will be helping you to install, uninstall, or upgrade a software or package. Okay. Now, what and all does this packaging manager do, right? Now, it basically helps us in ensuring that the application or the software that we have is installed and it is up and running. But it's not just a single library or a file, but whenever we say a package in Linux, it's actually collection of various files or libraries, which is what we need as a software to access. So from that way, now if you take Ubuntu and if you want to install some package like Java, or let's say I want to install Git, or I want to install Jenkins or Ansible, Docker, whatever that we are using in our day-to-day, if you want to install, then you will be saying something like apt install using a packaging manager called apt or apt in Ubuntu, right? So that's how you do the installation automatically, because here you don't do anything manually. You just enter the command apt install followed by the name of the package or the software that you want, and automatically the packaging manager that you are using will ensure that all the contents which is needed for you, which is nothing but the package, will be installed on your machine, right? Now, in the same way, let's assume that you have installed a package or a software, and then after some time you want to update it to a latest version. Then what do? Again, you use the same packaging manager with respect to the OS where you are working, and you would be using some option like upgrade to update your particular software to a latest version. Okay. Now again, you're going to do all these things with the help of a packaging manager specific to the OS. Now, when we talk about installing a software, there might be many dependencies which is having, right? Now, ideally, if you go back to Jenkins, for Jenkins, you need to have JDK available. The same way, if you say you want Ansible, for Ansible, Python is needed. But if you go back and remember, or if you have seen any installation like this, there is a dependency which is also taken care by the packaging manager, right? For instance, if I just go ahead in Ubuntu, if I say apt install Ansible, it will not just install Ansible, but before installing Ansible, it installs the required Python libraries or packages, and then it will install the Ansible package. So that is how the packaging manager ideally helps us to make sure if there is any kind of dependency that we have for our original software or package, it also installs all of them, right? And finally, if I say that I don't want this particular software and if I want to remove it or uninstall, and all the dependency should also be uninstalled. So that's how this again happens with a specific command that you interact to your packaging manager. So this is where a packaging manager is very important, where the term called package is nothing but collection of all the softwares that you want, where you tell how to install it or how to upgrade it. And in case if there is any dependency in it, if you just install your package, everything defined inside the package will be installed accordingly. The same way, if you want to uninstall, it will be removed. So that's how, with the help of a package or with a help of a packaging manager, you have to define the so-called package, which will contain all the softwares that you need, and you decide the installation or uninstallation or upgrading with the help of this packaging managers. Okay. And whenever we talk about a packaging manager, there's again a particular repository to which it is associated. Because now if you go to Ubuntu, for the example, if I say apt install and if I'm trying to tell some package name, now we need to tell the packaging manager where exactly is the repository, because Git might be available in a different repository, and then your Jenkins might be available in a different repository, Git might be available in a different repository, the Kubernetes components might also be in a different repository, right? So that's where whenever we are using a packaging manager, we also have to make sure that there is corresponding repositories from which the packaging manager will be downloading the packages which is needed and its dependencies, and it will install, right? So this is how we will be installing or maintaining a software or a collection of software, which is what we call it as packages on a machine. Okay. Now, with the same concept what I'm talking about, now replace the packages where we had something like Git or Java or Ansible or Python, and start putting your application in terms of Kubernetes. Okay, so that's when, if I go to a Kubernetes cluster, we are interested to make sure that whatever the applications that we are building needs to be deployed into that cluster, which is what we call it as installing them and making sure it is running. So that's where now, if you just take an example in which in my Kubernetes cluster, if I want my software or my organization's product needs to be installed, then what are the things that you need for it? So assume a simple two-tier architecture where I now have one front-end component in which I would be requiring a product which I need to run. But for that, if you try to define the object, then that is where for this I need to first define a deployment object. And in the deployment object, I'll be telling how many replicas that I need. And within this, you will be giving all the spec about how exactly your image will look like, your replica will look like, and all the other properties. All right. Now, along with this, it will not be sufficient only for the deployment object, but if my application also needs some kind of configuration which needs to be injected during runtime, then again in Kubernetes, we have an object called config map, using which I'll be passing some information. Okay. Now, along with it, my application also needs a port through which I'll be able to access it. So that is where now for this object, I also need another object called service, which will be helping me to expose the port to a cluster level or to the machine level or outside the cluster. So that's where now this is a combination where if I say that my software needs to be available in the Kubernetes cluster, or the build that whatever I'm doing of my product, if I need to make sure it is installed in my Kubernetes cluster to access, then I need a combination of all these things, correct? But it's not just one set of changes or one set of files that you need, because now if I want all these things, then we will be defining the so-called manifest file, which is nothing but YAML files in which we will be defining the deployment, the config map, and service separately. All right. And what we used to do, we will take this manifest file, go to the cluster and or go to the Kubernetes master, and we'll just use the API server, or you will be using kubectl and say apply against those file, right? But just like how we had dependencies in our packaging management earlier, like I said, for Jenkins, you need Java. For Ansible, you need Python. The same way, when you say that your application is more of just a front end, we also might need a backend to make sure that your application is running. So that's where if you take your backend component, that will again have a separate type of object, right? So let's say that if I need a database to be up and running, then I have to define a specific set of object called stateful set. And for this, I'll be defining a separate YAML file. And this will again not be sufficient, because if there is any kind of sensitive data that I have to inject during runtime, then again I might be creating a new object called secret specific to it. And how am I going to access it? So once again, I need a separate service object which is going to expose the port or allow us to access the database. So this way, now in Kubernetes, if I say that I want to install my software which I'm building, then I need both of them. So that is where instead of we creating multiple YAML files and communicating to the Kubernetes master separately and saying kubectl apply, what we have to now think is how can we treat the whole of this as a package? So this way, now, what if you can assume where instead of you doing the installation or running kubectl against the YAML files separately, if you have the whole of this as a package given to you, just like how in your Linux, you just say apt install git, apt install Ansible, you will be able to get everything which is needed as a dependency as well as the actual software, right? So the same way, now think if this entirely is given to you as a package in Kubernetes, then all you have to do now is install this package or upgrade this package or remove this package. So what will happen now? In your machine or in your Kubernetes cluster, if you need this entirely, if I have created it as a package and I'm just giving it to you, all you have to do now is go ahead in your cluster and say the install of this package. Just like how if I want Ansible to be installed, I'll just say apt install and the name of the package. And that package will contain the Ansible libraries, as well as it will also contain the dependency of Python libraries. And how does it install? It will install Python and then it will install Ansible. The same way, if these are my libraries or the software that I want to be available in my cluster, if I give this as a package to you, and if you install, we can set up dependencies also in such a way that your backend will get first applied and then your front end will get applied, and all of them will happen automatically. So that's exactly like how I was explaining you in the previous slide, where using a packaging manager like apt or yum, how do you make sure that a software is installed or updated or removed automatically? You can also now make sure in your Kubernetes cluster, all these things can be installed or upgraded or just removed automatically. Okay, so that's where the same concept of packaging comes in. So as we move forward, it's not just that we will be having one manifest file to define our deployment, but there will be collection of various manifest files which will be defining what exactly is a deployment for us. So just like how you have a Jenkins package or an Ansible package in your OS, now in Kubernetes, for us, we have to think about how I can create a package which will contain all this manifest file or the object's definition. So wherever I want, I can just go ahead and install, and the Kubernetes should be able to get all these things up and running. So such a way where we have to now think, how is that you're going to pass these components put together as a package, which is what we call it as packaging management in Kubernetes. Okay. So now comes the point is, like how for a OS we have a packaging manager utility which was like apt for Ubuntu, and if you say yum it'll be for CentOS, right? Like this, for different OS you have different packaging manager. So the same way in Kubernetes, if you want to create such a kind of packages and manage the packages, then there is a utility or a software which is what we call it as Helm. Okay. So Helm is nothing but a packaging manager which is exclusively used for Kubernetes. Okay. So using Helm, what we can do now, we can actually define packages. Okay. So now you choose what and all are the packages that you want to create, or what exactly a package should contain, what should be its dependency, right? So those definitions is what we can do with the help of Helm, and we can create a package. And ideally, once again, going back to the previous slide, now if you take a machine, in that machine, if it's a Ubuntu, and if I say apt installed and a package, I also have to tell from which repository exactly it has to be downloaded and installed. The same way, what we will be doing in Helm is you define what is the package that you want, and all these packages will be stored into a specific repository which is exclusively again available for Helm, which is what we call it as Helm repository. All right. So that's when now compare the same apt or the packaging manager, whatever I told you in the previous slide, with this. So now if you have a Kubernetes cluster, what is that we have to do is see what is the package available which contains all the components or the manifest that you need, and where is it available. That is a particular Helm repository which is needed. So all you're going to do is download the specific package corresponding to Kubernetes with the help of Helm, and this package is what you're going to install, upgrade, or remove. Okay. Now, as we are talking about it, let me talk about the architecture in the next slide. But before I jump, there are three major components or concepts that we have in Helm, which is very important for us to understand. Okay, so what are those? Now, the first one that we need to understand is what we call it as a Helm charts. Now, this is one of the biggest confusion where people don't get, is it Helm or Helm chart? So now if you understand, Helm is the utility which will help you to create the package in Kubernetes, whereas Helm chart is the concept. So what exactly is a chart? So now, as I said, for every OS, there is a separate type of packaging manager, right? Like apt, or you will call it as deb or yum or rpm tar, right? Like that. If you are creating a package in Kubernetes, it has its own structure or its own format. And that format is what we call it as charts. Okay. So which is nothing but, if I just go back, this package in Kubernetes is what we call it as chart. Okay, so we don't call it as a package because package is more a generic term which we use. And again, it's more for your understanding I was using. So now what you have to think is, when I say a chart in Kubernetes, which is nothing but a package which contains all the different definitions or the manifest file that you need. So that's what you should be thinking about. Okay, so Helm chart is nothing but the packaging format that we will be using with the help of Helm to define what I need to install, what I need to update in my Kubernetes. or in my Kubernetes cluster. So what exactly does the chart contain? Okay. Now, unlike your packaging manager in a OS, where if you say install, let's assume that I'm saying install JDK or install Ansible, I'll be actually having my libraries inside it. But in Kubernetes and in Helm, if I say a chart, we will not be having our application there. What is that we are going to have? We are going to have various YAML files, which is what we call it as manifest files. So with the help of it, Kubernetes later will be trying to create a object and download the image specific to it and then spin up the container. So that way, in Helm, chart is nothing but that packaging format. So the name is given to it as Helm chart. And what does it contain? It's going to contain various YAML files. So in fact, it is actually a folder which will be containing various YAML files which will be defining your Kubernetes deployment, right? Which is nothing but your manifest files. And now, instead of you taking up these manifest files separately and installing it or applying it, now you are going to install or upgrade this chart together so that whatever the definitions that you have based on the dependency, how you have defined it, the Kubernetes will ensure that we will be able to install this chart or a package by the help of Helm. Okay, so that's where we are not going to now do a kubectl apply against our manifest file, but instead we are going to put everything that is needed and create a package with the help of Helm, which is what we call it as charts. And now, for example, if I have a manifest file and if I want to apply it on my cluster, we will be finding out what is the specific chart in Helm which contains the manifest files which I need based on all the dependencies, and that Helm chart or the package is what we are going to install. Okay, so going forward, instead of calling it as package, we should start referring it as a Helm chart, wherein a Helm chart is nothing but a package which consists of the different manifest files which defines your deployment in Kubernetes. So instead of you going to this cluster and downloading a specific YAML file or applying the YAML file separately or one by one, we are going to put everything together, and this chart is what we will be installing or upgrading. Okay. Now, there is another term called as a release. So once again, it might be a little confusing. So don't confuse with the word called release with the generic software release. Okay. So in terms of Helm, what do we mean by release? So if you have a particular chart with you, which defines what and all are the components that will get installed in your cluster, if you install a particular chart in your cluster, that instance which is running is what we call it as a release in Helm. For example, in the previous slide, I told you that I have a chart or a package where I have defined one manifest file of a front end component and I have another manifest file which defines the backend component. Now, both of them put together, I can create it as a chart. And now, if I install this chart in my cluster, I would be having a replica specifically available for my front end deployment, and I would also have a replica which is available for my stateful set database. So that way, this both of them put together when it is running is what we call it as one instance, and that is what we call it as release. Okay, so every time when you say Helm install a chart, like how we say apt install JDK. Now, instead of that, we are going to say Helm install a particular chart name that you have. So when you say that, Kubernetes or Helm will be giving the details to Kubernetes, and Kubernetes will be actually running these objects, right? So that one instance is what we call it as release. And every time you install a chart in Kubernetes, Helm will be tracking it with the help of a terminology, what we call it as release. Okay. And in fact, now when you say that you are going to install, you are not actually installing a chart. The instance of the chart, which is what we call it as release, is what we are going to install or uninstall or upgrade. Wherein the release is nothing but the details of the chart, which is exactly running in your cluster at that time. Okay. So remember, release is the name which the Helm will be using to track what exactly have you taken from the chart and which chart it is and what exactly is it happening. Okay. And if you want to upgrade, then it will be the same release name. With the help of the name, you will be updating, or you can also now roll back. Because when you go to Kubernetes, when I say deployment, it's not just about spinning up a pod and running it. In case if I want to roll back due to any other issue, over here, all you are going to do is take the same release. In the release, you can choose to what chart it has to roll back, because every chart has a specific YAML file, and the YAML file will have a specific object definition. So everything, including the dependency, will be rolled back automatically. So that is how, whether you are installing anything or updating or rollback, everything will be tracked in terms of releases. Okay. So remember, now if I have my Kubernetes cluster, and if I want to actually install a chart, I will go ahead and say Helm install and the chart name. But when I'm doing it, it will ask me for a release name or a name called as release, using which I'll be able to track. Because later on, if I want to check the status, what is happening, I'll not be knowing the chart name. So what we will be using is the release name. And every time, if you keep updating or doing changes for the release, it will be tracking the information on what did you first installed for this release. Second, what did you upgrade? Okay, so that's how it will be keeping a track. And using this, we can also do a rollback, which will be very easy. Okay, so that way, chart is what actually you have everything defined, but when you apply it to your cluster, it will be running it as an instance, and that is what we call it as release. And release is what, as a user, we will be managing everything. Okay. And finally, where do we store all these, right? Because now I would have a separate Kubernetes cluster. I can install Helm in it, but for me, or for my organization, I can have a separate repository, which is exclusively again for my Helm, where we are going to store all the charts which is needed or maintained by our organization. Okay, so that's how, similar to how you have your Docker registry, where you're storing all the images exclusively. Now, in Helm also, we have public and private repositories, wherein there are some repositories which is available to all of us to take some charts. Okay. However, within an organization, we can also define to have our own private repository where we will be building and keeping our charts, which will be defining the manifest for our application. Okay. So that's how, when we are now going to use, you need to make sure to define what is the repository from which you want to work. Okay. Now, these are the components that we need to understand. Now, what is the other benefit of your Helm chart is? So let's say now these are the different environments in which I want my application to be deployed, or in fact, these are the environments where you will be having your Kubernetes cluster. Right? So you will be having a Kubernetes cluster for dev, and then QA, and then if you have any pre-production environment or production environment. Now, each one of them will be a separate Kubernetes cluster. And now, whether I'm going through my CI/CD pipeline, and if I'm trying to apply or take my application and deploy in all of them, now, in the terms of Helm, I cannot now create a separate chart where it will be having all the YAML files and the values defined in it specific to dev. That is because now assume that when I'm doing my development or as part of my CI/CD, I might have to do some kind of smoke test where I have to deploy my application. So now if I put all my dependencies and everything together as a Helm chart, and if I want to run it on my dev cluster, it might need probably only one replica. And for that, I might have to pass some specific database. So the config map, whatever I define, will be pointing to a values or the database which is used only in the development purpose. Same way, now when I go to my QA, I might need to have another chart where the values or the definitions that you have will be specific to QA. Because now, let's say I might not need one replica. In QA, I might need two replicas of my object. And same way, the config map content will also be changing. And the service type might also be changing. Right? So that is how when I create a chart for QA, I need to make sure all the values are specific. The same way when you move to your pre-production or production, if you want to use the chart should contain a manifest, and the manifest should have the values specific to each of the environment. Now that's where it'll be little difficult for us to maintain multiple copies of your chart, right? Because in fact, if you see, it's the same chart, but the definitions inside it or the values inside it are different. Okay, so that's where, if you understand, Helm also solves this problem, wherein we don't need to have multiple copies. So what we are going to do in Helm is, when we are defining our chart, what we are going to do is we are going to actually define a template. Okay, so template means, think of this way, where I would have my Helm chart, and inside that I would be having YAML files, but in the YAML file, the definitions or the values that I put for my keywords will not be there. For example, I want replicas, right? So let's say when you're defining your deployment object, you will use a keyword called replica. Now the value of the replica, we will not put anything. That is what we call it as template. So that now I can pass those values during runtime. Okay, so that's where in Helm, the chart, whatever we are going to define, will not actually have hard-coded value, but we will be creating it as a template. And the Helm actually has something called as a templating engine. Okay, so the template engine which is available in Helm will help us to take some values during runtime. Okay, and based on the values that we give, you can apply it or install the chart in a specific cluster. So that way, now let's assume that I have created a chart, and if I want to install it on my dev cluster, while I am installing this chart on my dev cluster, I can pass some specific values. So that I will say now replica is 1. The same chart, if I want to install it on QA, I will say replica is 2, or I will give the config map with the specific details. Same way, if I want to install the same package on my pre-production or production, then I might give the replicas as something different, or the config map will be different. So that is how it will be easy for us to create a single package in the format template, and with the help of the template engine which is available in Helm, we will be able to make sure that the values will be passed dynamically. Okay, so that's where now what we are going to do is, as part of your CI/CD, you're not actually going to just define a image or create a Docker image, but we also have to create a manifest file. That is what we were seeing so far. But now if you go through, we are not going to stop only with the manifest file, but we are going to create a chart which will be containing all these manifest files, but there will be a template out of it. Okay, and this template is what we are going to actually use and install on any of the environments we need. And when we install, we are going to pass whatever the values. So based on that, the content will be deployed into your cluster. Okay, so that's how charts will be useful for us. Okay, just remember this. And now coming to the architecture. Now, the latest version of Helm is what we call it as Helm 3. However, the previous version of Helm, which is Helm 2, Now, the architecture wise, there are huge differences between it, because when you take Helm 2 or the older version of Helm, it has a client and a server architecture. Okay, so that's where there is to be a client called as Helm, and again there is to be a server or a different component what we had called as Tiller. Okay, however, if you come to Helm 3, you do not have the concept of client and server. There is only one component which we call it as client. Okay, so how is it going to work? So assume that you have your Kubernetes cluster available, and so far what we were doing is, whatever the manifest file that we have defined, we will go to the cluster and we will say kubectl apply. That will be communicating to the API server, right? So instead of that, in Helm, what we are going to do, we are going to install the Helm client for a Kubernetes cluster. And here, with the help of this Helm client, we are going to say what exactly is the chart that we want to install or upgrade or remove from your cluster, for which there will be specific Helm registry available, which you need to tell to the Helm client, so that based on the registry, what you have told, or the repository, what you have told to the Helm will pick a particular chart of your interest, and that it will give it to the API server of Kubernetes. Okay, so when you say Helm install a package, Helm will be taking up or downloading a particular chart from the Helm registry specifically that you have defined, and give that to the API server of the Kubernetes. And from that, the API server will be communicating to the controller of master, and it takes care of ensuring that your manifest file which is available in the chart gets applied and all the objects or the pods get created. Okay, so this is how the Helm 3 works. Okay, so remember, there is no concept of server and client, or the component called tiller has been removed from the new or the Helm 3 version. So all you have to do now is, along with your cluster, you have to make sure that you have a package which is called as charts created, and which has all the definition or the manifest files templatized, and then install the Helm client for your cluster and install the packages whatever you want using Helm. So now you are not going to communicate to the Kubernetes API. You're going to use the Helm client, and the Helm client will be communicating to the Kubernetes API on the master. Okay, so this is how Helm is going to work. Okay, now as I said earlier, what we will do in the remaining session is, we'll try to take some existing charts, and we'll try to see how exactly we can use Helm to install or to upgrade or to roll back, right? So those are the things that we will see in this session. Okay, and typically on another session, we will see how we can create our own charts, which is a Helm chart. Okay, all right. Now, before we start, we need to understand that for Helm to work, or the Helm client to work, you need to have a Kubernetes cluster available. Okay, so for this practice, I'm just going to use a Minikube version or a Minikube installation of a cluster, so that everything will be treated as one machine, and the same machine will act as master and server, or sorry, the master and worker. Okay, so from that way, I'll take a Minikube machine which is already running, and in that, all you're going to do is download some specific version of Helm that you're going to run, and using this, you will be able to define the charts and start running it. Okay, now, so this is my AWS machine. Okay, so which I've already created, and I also made sure that we have the Minikube installed and it's running. Okay, so I have my Minikube available, and do I have any pods? Okay, So right now, I don't have anything in my cluster. It's kind of empty. So here, if I want to install Helm, then all you're going to do, okay, is try to download this particular Helm as a archive and untar it and then move to a particular bin folder. Okay. Now, this is what I've already done, but let me just show you quickly. So let me go to temp folder. Oh, there's a whole lot of things available. But anyway, this is the package, okay, that we just downloaded for Helm. And I'll just extract it. And when you extract, it's going to create a folder. So we have downloaded the package or the archive for 64-bit OS. And now inside this, you will actually see the Helm executable. So this is the executable. So what you're going to do is move this to a location somewhere which is available in your path variable, so that now when I say Helm, the OS knows this. Okay. So once it is done, if you just type which Helm, you can see it defines it is available here, and cross check by saying Helm version. So it's available. Okay. So that's it. It's very easy to install on the latest version of Helm, because in the older version of Helm, you need to have the tiller setup also, that is the server and the client. Whereas in the latest version, all you need is only the client. Okay. Now, so I have my cluster, which is my Kubernetes Minikube cluster. And in that, or in the master, I've just installed Helm, which is the latest version. Okay. Now, what is the next thing to do? So as I was telling, here, assuming that there is already a Helm repository available, and in that there are some charts present, we are just going to use the chart and see how, with the help of Helm, I can install or uninstall or upgrade my complete deployment of an object. Okay, so that's what we are going to understand. So when you talk about Helm, because again, start comparing with the OS packaging manager, whatever I defined in the very first slide. Okay, so that's the reason I told you there. So now, if I have to install a package, right, then the first thing I need to know, from what repository should I be downloading those charts, because in Kubernetes we define it as a Helm chart. So where is the repository in which we have our charts present, which is like a template? Because by default, the Helm 3 will not be coming up with any repository. Okay, because that was available in Helm 2, but in Helm 3 there will be no repositories available. Okay, now in case if you have defined some repositories for your Helm client in your installation, if you go ahead and say Helm repo list, it will be giving you the list of repositories that you have configured. Okay, so here if I say Helm repo list, okay, now this is what I have configured. Okay, I'm just using the stable Kubernetes chart which given by Google. Now if you go to your machine and if you just try to say Helm repo list, you will not be seeing anything, because by default the Helm 3 doesn't come with any default repositories. Okay, so you have to define. So how will you define? So you have to say Helm repo and add, and you're going to say what is the name that you are going to refer and the actual URL of your Helm repository or the charts repository. Okay, so going forward, this is the Helm executable or the client for which we will be passing various options to define what exactly we need. So that way, for managing the repository details, you are going to tell on your client the command or the option called Helm repo. Okay, and this is what I have already done. And any point of time, if you want, you can update the repository or even remove the repository. Okay, so let me just quickly remove and add it. So for removing it, I'll say Helm repo remove and the name of your reference. Okay, so here if I just say helm, repo, remove, and stable. So this is the name that we have given. And now if I say repo list, nothing. Now this is what you should be getting it as soon as you install the Helm client and run the Helm repo list, it will not be showing anything. So now if I want to add, then you can go ahead and say Helm repo add, and I'm just giving a name called a stable so that it's for our reference. Okay, so now I have added a reference called stable, which points to this URL. So if you go back and say repo list, now any point of time, if I'm telling to the Helm to install a chart, it will be looking into this repository. Okay, now like this, you can also add more than one repository available so that any actions that the Helm is going to do, it will be always referring to these repositories which has been defined. Okay, so that's where when you're working in your organization, you would have your own private repository for your Helm. So you need to define or add on where exactly it is. Okay, now once you have added the repo, the next thing is you need to know how do you access. But before that, there is an option called search, using which you can actually search for any available chart in that particular repository what you have defined. Okay, so for that you're going to say Helm search. Okay, now you're going to say Helm search repo. So when you say Helm search repo, it will try to search whatever the package or the chart that you want in the list of repositories that you have added. Okay, so that way, now just say that I want to search for any package or a chart available to install Jenkins. So if I just give some keyword, what it will do, it will try to search the repositories that we have added, and in that whatever is matching it will try to give us. Okay, so here it is saying in the particular repository that we have added, this is the only chart available. Same way, now let me just check. I want something for my Tomcat. So if I say repo search Tomcat, so it says there is one particular chart available in the repository that we have defined. Okay, so this way, this is one of the repository. Now, like how for Docker, you have Docker Hub, which is the public registry from where you will be downloading everything. Now, Helm also has a public registry. Okay, now that's what we call it as Helm Hub. Okay, now if you go to this site, that is hub.helm.sh, it contains various charts so that you can also use this directly. Okay, now in Helm 3, you do not have a method to refer to this particular repository or registry directly, which means I cannot say Helm repo add and I can refer this. So instead of that, when you're trying to install a package, you can refer to a chart directly with a URL, okay, which I'll show you later. So remember, if you're trying to use a chart which is available on the public Helm registry or repository, then you need to make sure that you're going to use the full URL. You cannot add it anywhere like this. Any other repository that you have, you can add. That's the reason I'm using another popular place from where we can download all the charts. Okay, now this is the one. So if you go ahead and say hub.helm.sh, and this will be having a list of all the charts, and this is how it acts like your Docker Hub. Okay, so now it has a whole list of charts available, so you can use whatever the charts that you need for your practice. All right, now the same, if you come back to your search, If I say repo, then it will be searching for the list of repos that we have added. Now, instead of that, if you say Helm search hub, it will be by default searching everything for this particular location. Okay, now see this. If I say Helm search hub, okay, and the same if I say Jenkins, you can see it's saying in the Helm hub, these many chats are available. Okay, so that is how it's all specific to a Helm repository you need to define, and based on that, Helm will be getting all the details, or all the charts will be referred from that particular location. So you need to choose where exactly is your Helm repository, and based on that, you need to add the repo and ask the Helm client to refer to that. Okay, but anyway, for this practice session, I'll be referring to this particular location. Okay, so that now anytime if I refer to any chat, the Helm client will be referring to the repo that we have just now added. Okay, so first understand how this works. Okay, so that's very important. Next, so now if you want to start your work, you need to first know what is the chart name available. Using that, you're going to install. Okay, so like I just showed you, now just an example. Now if I want to install Jenkins, now for that there is a chart available. So I can just say helm search and then my repo, and in that search for Jenkins. So you can see this is the name of the chart which I am going to install, or this is the collection of all the manifest files which has the definition on how Jenkins should be installed. Okay, so that way now before you install this chart, you can actually see what are the various definitions available inside it. Okay, again, I told you right in a slide where the Helm gives us a template. So that way, what are the default values which has been set in this chart or package? If you want to see, then you can use Helm show. Okay, so Helm show will be typically getting you the information about the chart. Now remember, this is before you install it. Okay, so even before installing, if you want to see what are the definitions or different kind of information that the chart is going to have, you can pull them. So that way, for that, you're going to use Helm show. And with the Helm show, you're going to say the chart name from which it needs to pull the information. And now every chart will actually have various files, because chart is not just one file. If you go back to the definition I told us, it's a directory which will be containing various YAML file. So that way it will be containing something called as values, or your information about the chart, and we will also have an additional file called readme which gives the description on how to exactly use. So that way there will be different parts of your chart. So that is where when we go to the next session on how do we create a chart, you need to know what are the parts of it and how do you define. But for now,
Unmuted.
given a chart to you, what are the values that you want to read from it, or what informations that you want to read from it? These are the options available. Okay, so just to show you now, let's say if I want to search for Tomcat or a chart for Tomcat, this is what I have, which is stable Tomcat. Okay, now if I want to read some information about this, then I can just say helm show, and what is that you want to get the information from this chart. So that's where you need to use any one among them, that is values or the chart information or the readme, or if you say all, it's going to get you everything. Okay, so now if I just say values, and this is the name of the chart. Okay, so if I just enter, it shows you a list of properties which are nothing but the values that this particular chart requires. Okay, so that every chart will also have a default value set. Now if I want, I can change these properties during my installation time. Okay, so that's where you can see this chart actually has various YAML file, and in those YAML file, these are the properties what they have used, which is what we call it as values. So now these are the predefined values which is available, or default values available. However, if you want, when you are installing this chart to your cluster, you can also pass or change this values. That is what I was talking about, the template engine. Okay. Now, just to show you, right, I was just trying to pull this option because it's always good before you install, try to see what and all are the options available. Okay. Same way. Now, these are the values, but we know that in Kubernetes, you are going to define everything through your manifest YAML, right? So in fact, when you say chat, it's also a collection of manifest which defines whether you need a deployment object or a config map or a service or a persistent volume, whatever that you want, right? So from that way, over here, what happens now, if you want to see that manifest file which is available inside this chart, then you're going to say helm show manifest. Oh, sorry, you're just going to say chart, not the manifest. So here it's going to define what are the properties of this chart. Okay, so this is where it's saying from where it's going to get, what is the version of this, right? And again, there are two different versions. One is app version, which specifies to the application version available inside the chart, and the same way, what is the version of the chart itself, not the application. So that's where there are different values. So all these things is what we need to see when we create our own chart. But for us now, it's just for understanding to know what is that we are going to install. Now over here, if I say all, okay, so that's where here you can see it's showing you a lot of information where it's going to give you the details on what exactly you have to do, how to install it, right? Same way, if you just go up, it also gives you the values that we have, right? So it's going to kind of pull up all the information which is needed. So that's where just try to do a Helm show and see what are the values that you're going to pass and how it is going to be defined. Okay. Now, still, we haven't installed anything. We were just trying to see what are the values that we are going to pass to it. All right. Now, the next thing comes is actually you're going to install. So that's where, what do you mean by install? Just like how in your OS, you're going to say apt installed in a package. Now you're going to use Helm install and specify a package name, and that will get installed on your Kubernetes cluster. Okay. So now every time when you are going to say install, you actually need to give a release name associated to it, because going forward, anything that you want to get the details about what you have installed, how it is running, then you're going to always refer to the release, which is nothing but the instance of your chart running in your cluster. That is what we learned some time back. Okay, so that way, now if you want to install a Helm chart, you need to first tell the repository from where it should be taken, and second, what is the name of your chart and what is the name of the release which you are going to use to handle it. Okay, so that's where you're going to say Helm install, the name of the release, whatever you choose, followed by the name of the chart which you want to get installed on your cluster. All right, so now, so you can see in my current Minikube cluster, I don't have any other objects other than this default service which is available, which we can ignore. But I don't have any pods or any other objects available, right? So now here, if I just say Helm install, and when I'm installing, I have to give a name to it. Okay, so I'll just say test Jenkins. Okay, and here I will tell what is the name of the chart which I'm going to install. So that's where the name of the chart which we had from our repo was stable Jenkins. Okay, so from this repo I'm trying to tell pull this chart name. Okay, now what will this do? As soon as you say install, based on the template whatever you have, it will try to take all the manifest file and apply with the default value in our cluster. Okay, so once you just say install, you can see it says it's deployed. Okay, and how do you access them is the definition, which is nothing but the nodes or readme. So in the previous command when I showed you helm show, if you had told helm show readme, then it will try to give you this details on how to access this Jenkins once everything is available. Okay, but typically now what we have done, we have taken the chart which is called as stable Jenkins and we have installed in our Kubernetes cluster. So this is where we didn't communicate to the kubectl. So we used Helm and we installed this chart, and the Helm client would have communicated to the API server of the cluster and told to run or apply the manifest file which is available inside it. Okay, to see that, now just I'll clear the screen. If I say kubectl get all, you can see now that particular Jenkins package has defined a deployment object, and a deployment object internally specifies a replica set, and it has one pod defined. Okay, and ideally they have also defined two services that you can use to access. All right, so this is how you, with the help of Helm client, you're going to install a chart, and the chart has the definition of your Kubernetes YAML files, which will be fed to the API server of your Kubernetes master, and that will make sure that it will be applied and it will be creating. Okay, so this is where now you have your chart, which is the Jenkins chart available or installed. And with that, you see that you already have your manifest file defined, and all the packages or the objects what you have defined is available and up and running. So this is how you choose your chart and you just say install. Okay. Now, just to show another example, I can just go ahead and say Helm install, and now you have to give a different release name. So let me say test Tomcat. And what is the chart from which you want to install this? So again, I'll refer to our stable repo, and from that, I have a chart called as Tomcat. So once again, what is it doing? It's saying that it's installing, okay, and it's deployed. And if you want to access it, this is how you're going to access. It's just a definition again, which is coming from the README. So once again, if you go and say kubectl get all, now in addition to your Jenkins, you can see there's a new deployment created. That means whoever has defined the chart, they have defined an object called deployment, okay, and with one replica. So that's where it's trying to create a Tomcat replica set, and corresponding to it, it is trying to define a pod, okay, and it also has corresponding service, okay, which is of the type load balancer. Now, if you see in our cluster, we don't have any load balancer defined, so that's where this service is still pending. Okay, so that is how when you are trying to install a chart, by default, whatever the definitions or the manifest available, it is going to take up. Now, however, if I want, I can also change the values, which we will see. Okay, so here we are just going to choose what chart we need and we are going to install. So this is how, rather than you taking up all your manifest file and saying kubectl apply separately, we are going to put everything as a package, and that package is what we call it as a chart in Helm. And this Helm chart is what you're going to install, update, or remove. Okay, now over here, if you see, what I have done is primarily installed two releases specific to one Jenkins chart and the other one is the Tomcat chart. Okay. Now, if you want to see what exactly are the releases available, okay, so you can just go ahead and say Helm list. Now I'll just come back to it. Now here, if I say Helm list, you can see now in our cluster, there are two releases available. So a release in terms of Helm is nothing but one instance of the chart that you have installed. Okay, so here you can see this is the first one that we installed, which is test Jenkins, and the other one is Tomcat, which is test Tomcat. And actually, if you minimize the font and see, it is actually telling what is the chart and what is the version of the chart that we have taken. So if you understand, when I just say Helm installed and the chart name, we were using everything by default. So that is where it has taken the latest version of chart and it has installed. So that's the reason here it's Jenkins 230 and over here it's Tomcat 41. Okay, so that way you specify what you want to install as a chart, and for that you're going to use the name, because this is the release name using which we will be doing the upgrade or remove or rollback. Everything will be based on that. Okay, now we'll talk about that a little more, but just understand for now, this is what we call it as a release. So remember, in this command, this is release because this is what you are going to refer. And how did you get it? This is the name of the chart or the package which contains all the YAML file. And in this, as we see here, we just use the default options, not anything specific. Okay. Now, any point of time, if I just want to delete them, then I can just go ahead and say Helm and delete, okay, and your release name. So if I just say release, it'll delete everything. Okay, so that's where you can see whatever this release is referring to as a package or the chart, it's going ahead and uninstalling or removing them. So that's when now if you go ahead and say kubectl get all, you would see that the reference of your Jenkins objects, it's completely removed. So that is how it's like how you say apt remove. You're now saying Helm delete or uninstall the particular release, and corresponding to the release, how did you get it? So this was obtained by a chart, and whatever the reference of the chart is available, it's going to take up everything. Okay, so that's how you are going to install, upgrade, or you are going to delete everything with respect to the release name. Okay, now quickly, let me just do the same for the Tomcat also. Okay, so now if you say Helm list, there's nothing available. Okay, so that's how it's quite easy for you to install or remove it. Now, just remember this Helm list, which will show you the list of releases available. Okay, now going back to the install, when you're trying to install, sometimes before installing, you might have to check or you might have to do a dry run and see how exactly it is going to get installed, what are the properties or the values that it is going to get, right? So that's when, before you are going to do an actual install, you can pass an option called dry run. So if you pass the dry run, it will not be actually installing anything from the chart, but it is just going to prepare and show you these are the values where it is going to install the chart. Okay, so if you're going kind of required to verify before you are going to apply the chart, then just say Helm installed dry run. Okay, so over here now kubectl get all, you don't have anything. So now if I say Helm install dry run, so it's going to give you the output where you can see it's showing you what are the values that it has actually generated, right? Which is nothing but your YAML definition. So this is the YAML definition for the Tomcat, which they have templatized inside the chart, and you can see all the values that it is showing. Same way, it also has a service definition, where in the service definition, what are the default values it is populated. So that's how you can quickly do a check. So before you are going to install, you want to check how exactly it is going to be applied and what is the definitions you are going to apply. You can use dry run. And in this, if I just say kubectl get all, you see nothing has been installed, because when you say dry run, it's just going to show you by populating what is the exact values that you're going to actually install. Okay, so this is again very much necessary, because before you do is just like how in Ansible you're going to do a check, or in Kubernetes, in the Terraform, how you're going to do a validate or a plan, right? The Terraform plan. Similar to that, before you install the chart, if you just want to quickly check and verify, go ahead and use Helm install with the option dry run. Okay. Then, if you have actually noted, as soon as you say Helm install, it will be coming out of the command by saying it is deployed. But for your actual objects or pod, it would take some time to come up, right? So if you're trying to automate something, and if you're trying to use Helm commands to automate, it would be giving you a wrong message, right? For example, here, if I say Helm install test Tomcat, okay, and here, let's say I'm saying stable and Tomcat. See, within seconds, the Helm command is saying it is deployed. But if you actually go back and say kubectl get all, you can see it's still running. It's not come up. So typically it will take some time, so that once the containers are up and running, then you will be able to actually access, right? You can see it takes time. So that's where, if you're doing some kind of automation with respect to your CI/CD, then you might have to ask Helm to wait until all the pods are coming up. Okay, so not just immediately come out by saying that it has deployed. You can actually ask the Helm client to wait until all the pods or all the definitions of various objects that you have in the manifest or in the chat, everything is up. Only then Helm can consider that, okay, I have actually deployed, right? So suppose if you have a requirement like that, then when you are using the Helm install, you're just going to pass additionally an option called wait. Okay, so when you say wait, what will the Helm client do? Helm will wait until all the objects which is defined in your chart is created and it is running. Okay, but by default, wait, how long it will wait? So there is another option called as timeout, which is again attached to it. So by default, timeout will be around 30 seconds. So when you just say wait, it will be waiting for the default timeout, and beyond it, it will not wait. So that is where you can also pass along with wait, what is the timeout until which it has to wait. So it's a combination that you're going to give. If you do not give timeout and if you just say wait, there is a default time that you're going to have. So based on that, it will be waiting. So that's where always you can give a combination of all these. All right. So just to show you, now what I'll do, I'll just I'll just delete the release. Okay, so we don't have anything now. Okay, so here if I say Helm install and wait, okay, and timeout. Now just for demo purpose, I'm going to say 10, because earlier you noted within 1 or 2 seconds it was coming out, but now it will be waiting until 10 seconds. Okay, and then here we'll just say our release name followed by what is the name of the chart. Okay, so if you can start counting, it'll be waiting for exactly 10 seconds. probably 3-4 seconds is gone. Yeah, it'll just come out. Okay, so you understand, it's not stopping your package installation. It goes ahead with it, but this wait command for the client is timed out. That's it. So don't think that when I say timeout, it's going to stop the installation of the package. No, that will go, but the time that you are waiting, that the Helm client will be stopped. Okay, so that is how you need to understand and give the option, so that if you want the Helm client to mark it as deployed only when everything under the objects spec what you have defined in the chart is completely deployed and it's up and running, then you need to give wait with the appropriate timeout. Okay, now let me just delete test Tomcat. So that's where when you say install, you need to specify some options. Now in addition, if you take a chart, right, every chart has a version. Just like how you go back to your Docker images, when you try to use an image, you will be using the version with the reference of a tag name, right? The same way, every chart has a version, because if you are trying to create a chart, first assume that you're uploading your chart. When you're uploading, how are you going to track what changes you have done? So that is where every time you modify something, you need to give a version to that chart, using which the user can choose which exact version of the chart that he or she can download and use. So that's where if you now go back to any of the chart, now let's say this is the chart which we had, or the Tomcat that we were using. Over here, you can see there are various charts available. Okay, so based on this, which chart that you want or which version that you want, you're going to use them. Okay, so now ideally, watch this. If I go back and if I just say Helm and install test Tomcat, stable and Tomcat, and now I'm just jumping ahead a little more. So I'll just say Helm and okay, list. You can see that what we have taken is the latest version, which is 0.4.1. So that's where now you can choose which version that you want to install, or typically take it for your package by adding a new option called --version. Okay, so this will tell you not to take the latest, but a specific version of the chart should be installed. Okay, so this is what we have. Okay, now here same chart can be created, or we can create multiple release with it. Okay, so what I'm going to do now here is, you can see what happened. It's the same chart, but I took it with a new release name. So that is how the same chart can be applied as many times that you want, but for every time that you're installing, you need to give a separate release name. With that, it's going to be a separate instance. So that's how you can see this release name, which is called as test chart, refers to 0.4.0, whereas the previous one that we had refers to 0.4.1 version of the chart. So that is how you can choose which version that you want. Accordingly, whatever the manifest has been defined, that will be deployed into your cluster. Okay, so this is how there are various options that you have when you use Helm install. Okay, now when you actually see that I told you every Helm has a template and you can actually pass some values. So that is where it's not mandatory that when you're installing, you should always take the default values that is defined in the chart. Because so far what we did, Every time I just went ahead and applied, I was just trying to take everything as the default value, correct? So that's where if you want to customize the chart based on your environment, so while you're installing, you can pass values. So that is the reason first I showed you that Helm show, wherein it was showing you the various values that it has been templatized and what are the default values that it has taken. So now when you are saying Helm install, you can choose what are the values that you want to pass accordingly. So for that, there are two methods you can do. Suppose if there is just one values or two values that you want to pass, then you can use a parameter called -set, using which you can pass some values. But suppose if you have multiple values that you want to pass, like replace the entire default values with your values, then you can put them together into a YAML file and use another parameter called values or -f. Okay, so these are the two ways that you can have. Now, let me talk about this -f later when we know how to create a chart, right? That point of time, we will be knowing what are the exact values that you're going to give, and then we'll come back and see. So for now, I'll just show you how I can just pass one or two new values to my chart and change the properties during runtime. So for that, we are going to use set. Okay, so now just to do, so let me just go ahead and Helm delete test chart, and I'll just delete Tomcat. Now you don't have to do all those things again and again, but just for me, if I try to show you, the screen will be full if I've been doing this again and again. So that's the reason I just uninstalling so that whatever we do, it's clear. Okay. So now what I can do is I can go ahead, I can try to install. Now in this, what I'll do, I'm going to change the type of service when I install this package. Okay, now probably let me do this once and show you. I'll say Helm install test chart. This is my name of the release, and stable Tomcat. This is my chart name. Now once it is done, let's say kubectl get all. You can see that the Tomcat service type is mentioned as load balancer. Now, if I want to change this, so this is where first you need to know what is the corresponding property name which is going to take the value of it. So that's where you're going to use the Helm show and try to find out what are the values that it is going to take. And based on that, what we can now do is when you're going ahead with install, you can say set, and for the set, we are going to tell what exactly is the that property and what is the value that you want to take. Okay, now let me show you this. Let me go ahead and delete this. Now I'll say Helm show, okay, and values, and in this, let's say stable Tomcat. Now if you just come up here, so this is where there is a property called as service, and under that there is one more child property called as type. So now if I am interested to change this value, then I need to say service dot type, which is nothing but the parent property dot the child property. Okay, so this is how you'll be defining. In case, just an example I'm telling you, if I wanted to change this, I don't have to say any dot. I can just say set host port equal to my new value. But over here, there is a parent key, and under that you have a child key. So you're going to say set the parent key dot child key. So that's where service dot under that I want to change the type. Okay, so that's what we will do here. So I'm just trying to change from my chart installation the type of service to be node port. Okay, So it has done, right? And again, the name of my release is test chart 2. Now, just to show you, I can just go ahead and say kubectl get all, and you can see now, instead of taking it as a load balancer, because of whatever the type that you have defined, it's been taking that. So that is how it's not mandatory that you should do install by the default values. So the Helm has a template engine where you pass whatever the values that you want. So like this, I can also pass multiple values, or I can just create one YAML with all the values and ask the Helm client to read that, which will be having the values. Okay. Now, this is how you're going to customize. However, once the chart has been installed as a release, if you want to get the information about what you have installed, then you are going to say Helm get. Okay, so remember, Helm show was before you install from the chart whatever is available. If you want to see, that is Helm show. But now, if you have installed a chart which is a release, and if you want to get the details of the release, then you're going to say Helm get. And for this, you can say whether the values or the manifest file, or you're going to say all, and accordingly it will be giving you everything. Okay, so watch this now. So this is my release name. So if I just say Helm get values from this release, you can see it is going to show the user defined values. So this is what we have passed, right? Now, if I want to see for applying this chart, what are the manifest file it has used from the chart. So if you go ahead and say get manifest, so now it'll exactly show you what was the manifest which has been applied, and because of that, when I did a kubectl get all, it was showing you all the details. You can see this is the definition where the actual YAML file which has been applied. Okay, so now based on what values you change, it would have been updating it, and then that is what it would have actually installed. Now, if you go back, this is where what we changed. So we have the service, and in the service definition, we had the type defined as node port. So whatever the value that you passed here, it has updated inside the service YAML file, and that is what it has actually applied in your cluster. Okay, so that's where now any point of time after you have installed your package as a release, if you want to see the details about what and all it has been done and what is the manifest file you have actually used for installing, that you can get it through this option called Helm get. Okay, so that's about Helm get, where after you install your package as a release, then at any point of time, if you want to see what is the status of your release after you say Helm install, you can go ahead and say Helm status. Okay, so if I now say Helm status and give the name of your release, so it's going to give you the properties, because in every chart there will also be a file called as readme. So along with that, it will be giving you the full information. So it's saying this is the one, and what are the default details. And one more important thing that you need to know is in Kubernetes, if you just go to a cluster and say kubectl apply, where does it get applied? So it get applied to the namespace in which you are working, right? The same way, I'm just going inside my minikube and I'm running this command. So what is the default namespace in which I'm working? That is again default, because right now we have only one namespace. So that is where whatever the commands that you run against your Helm client is getting executed under your default namespace. So that's how you also have options to choose against which namespace that your Helm client should be installing the packages. That is also something that you can choose. But if not, remember, Helm is kind of communicating to your API, which is your Kubernetes API server. And API server takes everything with respect to your current namespace, which is default namespace. Okay. Now, We saw how do we install a chart and how do we see the details about the chart, and while installing, what are the different options that we can pass. All right. Now, every time you try to take the same release and do any changes, the Helm is going to ideally keep a track, which is what we call it as history. Okay. Now, when I just go ahead and say Helm history, and if I give my chart name, you can see that there is only one version. Why? Because this is the first time, because every time I was deleting. In case if I have not deleted and if I just keep on doing a install, then every time I do a install, there will be a new version which will be tracking. And using this, we can actually go back, or it will be helpful for us to roll back, because that is where, assume that I have many manifest file which I have applied together as a package. But any point of time, if I want to go back with the help of history, I can find out what are the different versions of my release, and I can choose to go back to a particular version. Okay, so that is how, if you want to see those details, then you're going to use again Helm history and the release name. So this is where, remember, chart is only for the beginning. After that, you are always going to refer in terms of your release name. Ma'am, can you go ahead and remove your video, Suresh? Thank you. Okay, so now, why did I tell this? So this is where, let's now try to do some upgrade or rollout. Okay, so what do you mean by rollout? See, it's not that you will just say Helm install for the first time, because when you have a new cluster, for the first time when you are trying to install, or when you're first time trying to bring up your pod, then you will say Helm install and a chart name. But if I have a new build which I have done, and if I want to replace my existing object or my existing pod with the new pod corresponding to the new image what I am taking, that is what we call it as rollout. Correct? So that way, I don't have to create a new release. So the same release we will be updating. Okay. Now for that, we need to tell which chart to use, and in that it will try to recreate your pods. So that is how every time you do a build in your CI/CD, you will generate a new image. Now, corresponding to that, when we have Kubernetes and Helm as a package manager, we also have to create a new version of your chart. Okay, so remember, in Kubernetes going forward, it is not your image that you're going to deploy, or it's not the manifest file, but in your CI/CD, you will build your product, which could be a jar or a var or a tar, whatever it is, and put it inside an image, so that for every build, a new image will come. However, for every new image, you're going to update your chart version in your Helm. So that is where, for every build, you are going to actually create a new version of your Helm chart, and that is what you are going to install or upgrade. Because if you already have the chart deployed as a release, you are going to just update the release, not keep on saying Helm install every time. Okay, so what do you mean by that? I'll just show you. Now let me just quickly delete it. Okay, now just to demonstrate, assume that I want to install the chart, which is what I call it as the Tomcat chart, which is available. Now, this is my first time. So what I'll do, I'll just say Helm install the chart, and I will use a particular version. So let's assume I want to install 4.0 version of my chart for Tomcat. Okay, then let me just copy paste this command. Here is that. Yeah. Okay. Okay. So what I'm going to do, so watch this. I'm creating a release called test chart, and that is using a stable Tomcat chart with the version called 040. Okay, and now if I just go ahead and say Helm history and test chart, you can see that this is the first version and it is running my chart of the version 40. Okay, and corresponding to it, it has an application of version 70 of this whatever we have. Okay, so now assume that I have deployed and maybe this is my QA or this could be my production, whatever is my environment. I'll be having my pods up and running accordingly. Now when a new build comes and now I want to update my existing release with the new definitions that I have in my chart. So that is where the chart name can be the same, but the version will be different. Okay, so that is where now I can go ahead and just say Helm update or upgrade. So that is where I'm not going to say install again, because when you say install, a new copy of pods or objects will be created. But what I want is to replace the existing one. Then you are going to use Helm upgrade. So this is where whatever the current release which is referring to a particular version of your chart is being deployed, it will get updated. Okay, so that's where now you're going to say Helm upgrade, what is the release name, followed by what is the chart name that you want to update. And now whatever the earlier options that you had for Helm install, you can pass all of them. Okay, so here what you're going to do now, if I just say this, now I'm not passing any version. So what will happen? It will be taking the default version, which is 4.1. Okay, now because of that, if I go back and Helm list, you can see it is still only one release available, but I have two versions. For this, if I go ahead and say Helm history, and now you can see this was my first version. However, now I got the second version, which is on the latest one. So this is how you can upgrade an existing release. Every time you don't have to do a install. So install is only for the first time. After that, for the same release name, you're just going to give the new version of your what? New version of your chart. And now internally, if you go back and say kubectl get all, you can now see it is the same deployment object. Okay, the only thing is it is trying to create a new pod for it. Okay, and corresponding to it, you can see for your old version of your chart, it had a different replica set and trying to bring this up now. So that is how what Helm will do. It will try to maintain the same release, but with the specific version, whatever that you're trying to define. So it's not going to have multiple copies of it. So that's where it's always better that if you have a new build to update, now you need to understand you have to create a new image and you have to create a new version of your chart. And that is what you're going to upgrade, not install again. Okay, so right now we are working on this. Now assume if my chart had many other objects dependency and everything will be installed or upgraded together. The same way, now I had some issues and I want to go back because now once I have rolled out a particular build or a particular version, I have a issue and I have to roll back to a previous version. So this is where understand when I say roll back, it is not just recreating the pods that we have, but all the dependencies should also be moved back, right? So that is where with the help of this history, whatever we have, we can easily roll back. Okay, so now over here, see the old version is not running and the new version is deployed. So if I want to just go back and start having the previous version deployed again, then you can just say Helm rollback, which is what is very useful for your deployments in Kubernetes. Okay, so just say Helm rollback and what is the release name that you want to handle, and in that, what is the revision to which you want to roll back. Okay, so if you do not give any version, it'll always go to the previous version which is available by default. Okay, so watch this. So now if I just say rollback, okay, all it would have done is it would have now, see, its version, and it's now pointing to 3. And according to it, this rollback also would have created a new version to track. So that way, currently, what is that being deployed? Your Tomcat chat with the version called 040. So that is how all the dependencies with respect to this will also be reverted or rolled back to the older version. So that is how going forward in your Kubernetes cluster, when you say you want to install your application or deploy your application, it is not your image and the manifest file, but you are going to put everything together as a chart. And that chart is what you are going to install. And if you want to update your build or image, you are going to refer to the existing release, and that will be pointing to a particular version of your chart, and that's what you're going to upgrade. Or if you want to roll back for a particular release, what chat version that you want to roll back, or the version of your release that you want to roll back. So that's where your install, upgrade, or removing or rollback, everything happens with respect to the chart version that has been referring to the release, or release is the instance which refers to all of them. Okay, so this is how you're going to actually do the deployment. Okay, and corresponding to it, remember, anything that you're going to actually set up as a CI/CD as a customer or as an end user, that if I am interested in deploying my application in your Kubernetes cluster, so what you're going to do is not just define your manifest file and say kubectl apply, but instead we are going to now define our packages in terms of Helm chart, and this is what we are going to deploy. Okay, so that's more about how your Kubernetes will be interacting with Helm. Okay, now before I close, you also need to know one more part, because at some point of time, if you guys are very eager to know what exactly is there in the chart, right? So that's where you can actually use a command called Helm pull. So what will Helm pull is, it will not install the chart, it will just download the chart to your current machine or your current folder or workspace so that you can explore it. Okay, so for that, go ahead and say Helm pull and give a chart name. Okay, so now, okay, there's too many things. So let me go to my home folder. All right. Okay, ignore about this. So I'll just create a folder called charts, and let me go inside charts. Okay, so I don't have anything here. So in this, if I say Helm pull and let's say stable and Tomcat, you can see it downloads a tar. Okay, now this is the tar, which is what we considered as a chart. So in fact, now if you understand, if you go to any registry and if you look at it, your Helm charts are nothing but your tar files which contains all the definition of your manifest. However, now while you are trying to pull, you can also go ahead and untar it. Okay, so if you want to do, just go ahead and say untar. So it will not just download the tar file, but it will also extract it. So that way you can see here, now it has extracted to a folder called Tomcat. So if you go inside it, now this is the structure of your chart. Okay, now as I said, this is what we need to now learn, what exactly is each one of them, how you're going to get. But typically, just to have a look, you can understand inside this templates. So this is what is the template engine that I was talking about, where you have storing. Now here you have the definition. So if you remember, when we did a Helm get, it was trying to show two files. One was app server, the other one service. So this has your deployment object on how many replicas, what image to take, and this has your definition of your service. So that is where, using this template, Helm was trying to take some default values and generate the actual manifest, and it was applying. Okay. However, when you try to pass some values during runtime, that will be overwritten with this template what you have. Okay, so now try to do a Helm pull and see how exactly your chart looks like. Okay, and any point of time, as I told in the very beginning, when you're trying to install a chart, you can refer to a location of the repository, or I also told you that you can have your own registry setup or repository setup, and from that you can refer as a URL. If not, if you have created your own chart and if you want to test it, then while installing, you can either refer to the chart name with respect to the archive what you have downloaded or what you have created. If not, you can just refer to the current folder where your chart is and it will get installed based on that. Okay, for example, now assume this is my current chart what I have. Okay, and this is what I have created. And now if I want to do a test and install, then I can just go ahead and say helm install the name of your release. And this is where, instead of referring your chart coming from a repository that you have added or giving a URL, you can just either give the name of your tar file, which is nothing but your archive, or if I say dot within my chart folder, whatever I have, it'll be picking up that. And okay, it says the chart name is already available, but anyway, I can go ahead and create a new chart. So you can see it picks up everything from this. So that's is where there are many ways that you can install. So either you can add a repository and tell Helm to directly download from a repository that you have added, or you can try to tell that what is the URL of your repository directly, and from there it can directly download and take it up, or you can create your own chart and give it as a archive, or you can typically give it by saying what is the folder location from which your chart contents are available. So in this example, I just extracted, went inside and did a dot. So that is how you can also create your own chart, specify which one it has to pick up. Okay, so that way, remember, going forward in Kubernetes, it's not that you are going to just create an image. You need to create a Helm chart which is going to define your package, and that's what exactly we are going to deploy. So that anywhere in interview or somewhere, if someone asks you what you're deploying, you're not going to say I'm deploying my manifest file. You're going to use the package, and with the help of Helm, you're going to install that package, and that will communicate to the Kubernetes API server, and that is what is going to deploy or create the objects and the pods and internally the containers based on the manifest or the template what you have given. Okay, so that's from Helm chat, so that you would have been clear by now on what is Helm and how does it helps as a packaging manager for you to deploy. Okay, yep, that's what I have for this session, and let me stop it for now.